Now, the original call here was that the unit was going off and they had no heat. That was the original call. So when I got this services, the office downstairs, where we walked through to come over here. So there's Honeywell thermostats down there that control these two units. Now, what was originally happened here, this has a twin control. This twin control basically does what it says. So it twins two furnaces together. Okay. You can see on this side here that both supplies go into the two furnaces and they tie it to the same ductwork, right? And same thing here on the return side. So you have supply and a return side. Now, this thing was giving an error code of a high limit tripping. Okay. Now it was saying limit tripped. So now it's your job to figure out what limit tripped. And the particular limit that tripped was this guy right here. Now this guy is called a high limit. Okay? In the event that the furnace for whatever reason overheats, it trips off. So the first thing that we checked on here was the filters, because that's going to mean that there's a restriction of air. So air is not passing through, we are overheating on one side, and then obviously it's causing everything to get hotter. This thing has a certain degree rating that it trips off, and it basically breaks contact to the whole heating cycle. That's all it does. So it's basically a switch in series with a bunch of other safety switches that if it overheats or it gets to a certain amount of temperature on this side of the system, boom, it shuts off, right? So the first thing you check when you suspect that this is a problem is airflow. So airflow is going to be an indication of are we moving the right air? Is the filter clogged up to the point where we can't move enough air? You know, stuff like that. So my filter's checked out fine because the filter was fine. The reason why I'm changing is because they haven't, had changed it in a while, so I'm just going to take care of it. But the next thing to check is that, very rarely did this switch go bad, okay? In today's unfortunate event, this actually did go bad because of how many times it probably tripped. But this is also bad. But the next thing that we check after you check your filter's fine, is going to be your blower motor. You check your capacitor, make sure your capacitor is giving the right microfarad reading to the blower motor. You check your voltage coming from the board to the actual motor. So if my original call, like this thing was running, but this one I couldn't get the blower to kick on, thus giving you that error code. So I checked the voltage. We had a voltage coming from the board to the blower motor during a call for heat. A blower motor, this is a very basic PSC motor. So PSC stands for permanent split capacitor. It's very basic. So you're gonna have your heating, your heat leg, your cooling leg, your neutral, and then the other two are just two different speeds that you can, adjust it if you wanted to. But in this case, like when the heat came on and that thing never kicked on.
So what voltage did you?
120 volts.
120 volts to see there.
So you'll send 120 volts to the blower motor. The blower motor will then energize and kick on as long as obviously you have a good capacitor and everything's running operational. Now, I tested the capacitor. That is a 40 microfarad capacitor. The capacitor was no good. Okay, so I was getting voltage from here, so that tells me that the board is doing its job. So it's not a board problem. It was a mixture of capacitor and the motor failing. So that's why today we're going to be replacing that motor. And now we're just going to start taking everything apart, and you'll see how I do that. So first of all, usually, obviously, this whole blower needs to come out. So we're going to move this whole board out of the way.
So how did you get it to pop up the code that you needed?
Yeah, so the code, basically, a furnace is always going to give you LED signals here. Now, every LED signal corresponds to a certain code of a certain thing that can happen within the unit. Now, that doesn't necessarily mean, for example, if it tells you, pressure switch open, block in the exhaust vent, right? It means that the pressure switch for whatever reason did not close. It doesn't mean that the pressure switch is bad. It means that either didn't close because maybe the inducer motor didn't run, right? Or something happened. This is the pressure switch here. So this basically, again, creates a contact. This basically starts to essentially create a negative pressure over here. So it sucks air in as it exhausts out through the exhaust pipe. And then this guy closes these 2 points of contact. This is a normally open switch. So what does that mean? It's a very good thing to understand normally open, normally closed. Because normally open, it means that usually if I put my leads right here to this switch, there's going to be no continuity, right? When I suck through this hose, you're going to get continuity through here. And then that's a normally open switch. Normally closed would be the opposite. Like if I put my leads right now to this thing and have continuity, that means the switch is closed. So again, this particular code could be many different things, right? That's why this code, that the high limit is open, which you'll see here, it'll throw let's see, flame sensor, open rollout switch. You'll see where is the main power and proper main ground control and correctly open rollout switch circuit. Flame sense, watch guard build and fail. Here, this alternating slow flash, alternating slow flash.
Okay.
Burners fail to ignite, limit open more than 3 times for 3 minutes. And you lost flame sense 5 times over a heating cycle. See, so this should throw a bunch of shit at you.
Yeah.
But it's your job to understand that what this does. So this is a high limit switch. So a high limit will trigger if we overheat.
Okay.
So now in your head you're like, okay, well we're overheating. Why are we overheating? Am I not moving air? Is my filter clogged?
Yes.
Is my blower running? You know, are we getting power to the blower motor to make it run? Because your heating cycle operation, basically when you call for heat, this thing kicks on first. This thing then closes. This sends a signal back to the board telling the igniter right here to start glowing. Like this little guy right here, it's gonna be very hard to see, but right here,
Yeah.
it starts to glow. Once it glows, then basically we're gonna send a signal to the gas valve. The gas valve is going to open, allow the gas to flow through this manifold into the burner chamber in there, ignite the gas, and then this guy right here in the bottom is called your flame sensor.
Okay.
Very common thing that if it gets dirty, it makes a lot of problems. So we clean those every year. But the flame sense then says, hey, there's a flame. It rectifies back to the board and says, hey, I have a flame up to a certain amount of microamps readings or voltage, and then it sends a signal to the blower motor, or essentially the board will say, okay, good, we'll switch her over a relay, and it'll send a signal to the blower motor to kick on,
Okay.
based on that call. And that completes the cycle right there.
Yep.
Okay, so the last thing that comes on is your blower motor. Now, the blower, everything was happening, everything was cool, and then the blower motor will never kick on.
Okay.
And eventually, that thing, boom, opened up
And then shut it all down.
and shut it all down. Exactly. Let's see if we can get away without doing too much here.
So here I was telling my apprentice that it's just a good practice to label everything. As you remove the wires from the board, make sure you obviously put them back where they belong. It is also a good practice to read schematics from the furnace paneling, so you can get used to the typical signs, the electrical signs for what different things mean, where things should go, not just by taking a picture or label them, but it's just always a good practice because we are using the exact same board and the wiring is all going back. Now the only thing you have to make a note of is that the speed corresponds to the right color tappings on the new motor and the old motor, that they're all the same, obviously, because we are going by colors of the wires, which will correlate to a RPM and or a speed on the new and old motors. So we did go with an OEM motor, which was the exact same one that we were removing, so they're going to be all the same. But again, we just label everything out, and right now we're just in the process of taking this down so we can actually start to remove the blower.
So now what we're going to do is, obviously usually there's a one screw, in this case two,
Okay.
because this is a bigger bit of a heavier horsepower motor, but this basically holds the shaft together, then you're able to slide that down.
Okay.
You have to knock because you won't have access to a ladder.
Okay.
Alright? So what I like to do typically is just throw some WD down in this area right here,
Okay.
just because there's always a pain in the ass. Sometimes they come off easy, sometimes they don't.
Yeah.
Just throw some WD in there. And do me a favor, let's take out this capacitor.
Yep.
So undo those. That should allow the capacitor to come right out. There you go. Now what I want you to do is, now this is very hard to see, but usually you'll see like a 40 MFD right there, very faint, but you'll see the 4 and the 0 MFD. Now, even though we're putting an OEM back with an OEM, you always want to verify. So on the motor spec, you'll see the microfarad reading for this one. You'll have the the speeds.
Yeah.
So medium, low, high, depending on the color you are, and then right there, 40 MFD. Okay.
Okay.
So what we're gonna do is you're gonna get the capacitor right here. You're gonna put it back the exact same way the other one was. The bracket should be able to fit and everything's fine. Yep. Yeah, make it so that you can see the 40 MFD right there, perfect.
Positioned right.
Yep. So if in the future somebody comes, they don't have to take out the bracket, they can just,
Yeah,
see
just
and take
look
out
at
the
it,
wires.
yeah.
Mhm. Alright, so the next step is, this is a service wrench.
Yeah.
Typically you use this to also open up and close condenser service valves.
Okay.
Like when you gotta open up the refrigerator lines
Yeah.
for the condensers. But also, this guy particularly fits pretty good on this end of these guys right here, right there. So again, you can use a flat, you can use an adjustable, you can use a flat jaw channel locks, whatever you want to use.
Well, you found
But
that
this
to be
guy,
the
I
best.
found that it actually works right there perfectly. So you loosen it up. There you go. Loosen up the other one. Just be careful when you're pulling down against it because you will slice your hand here.
Yeah,
Just
my
be
hands.
be very careful with that.
Okay.
And there we go. You saw that? How the
How it
shaft
just
dropped?
dropped like that?
Yeah, like that. That's what we want to see. That tells me that it's gonna be nice and easy taking this out.
Okay.
So now we're gonna do is we're gonna flip it around. Okay. And now these bolts right here, we're gonna be taking these off. So obviously it's gonna be bigger. So we're gonna use 3/8. Again, the reason why I like this is because you can change.
It's got
all the
plenty of
ones
sizes.
you're pretty much gonna need. So here, just do these. Take these out.
Yep.
You never want to crank these down with a drill unless you're using like a soft, like you don't want to send it because you will strip it and you will fuck it up. So just try to do it by hand whenever you can, or even like a ratchet, that's fine, but don't do it with a drill. Good. Obviously save those bolts, they're important. Now what we're gonna do is just take this guy to here. This is my ground.
Oh, the new one comes with a ground strap.
Yep. So we're gonna take this out. Okay. Now, in theory, you should be able to just pop this out. Put your hand right here, hold this down. And that's where it becomes a problem.
So here's where everything went to shit. Like, it was not an easy swap at all. I mean, you'll see why.
Now they do make a fan puller, but I'd rather not go get it. We don't have to.
Okay.
But they do make it, and I have to. I was really hoping we didn't have to use it. I want you to give this shaft. I'm gonna hold this up.
Oh yeah.
Just give it like a quick hit.
Yep.
See if we get lucky. Go for it. We are not that lucky. You put the switch in there?
Yeah, I want like
Nice.
hand, like kind of like hand tight. I go super. cranked
Super
out.
crazy with that. Okay, no, that's fine. No, stuff like that, there's no need to go crazy.
Yeah.
I mean, it's got a gasket on it, as long as,
As long as it's
it's in there, yeah.
Alright, so I'm gonna just speed this up. But what we're using right now is a shaft puller or fan blade puller. We use it to take out obviously motors that are stuck in the blower housing. So it just makes the process easier. Basically, that rod, it pushes down in the shaft as we tighten it close to the ring that holds the shaft together, and then we crank it down, and basically it pushes the shaft out of the housing. But yeah, we kind of had a hard time with the taking out of the old motor and putting the one in. So luckily, this made the process a lot easier, and you'll see once we get the thing back up on the furnace. So right now what I'm doing basically is removing the squirrel cage or the blower wheel, because we are going to be cleaning it out. There's no need to replace it. It doesn't look rusted, corroded, deteriorating, or anything like that. So there's really no sense of replacing that. So I am gonna, however, remove it because we don't want any buildup in that cage, which can cause obviously premature failure in that motor. So we're just gonna clean it out real well. Just to make sure that everything, it's going back correctly the way that it should. And I'm just showing my apprentice here how to tighten up the band on the belly band on the new motor, which actually I made a mistake because I put him too far out of the motor, so the shaft didn't line up. Later when we went to put the wheel back on, but I'm gonna skip over that. But yeah, just make sure that you line them up kind of more or less to where the old belly band used to be. So I just showed him how to clean the wheel. So I'm gonna have him do it in a minute, and then we'll put all this back together.
An asshole because you actually had it in the right spot in the beginning. So see, I made mistakes. You're right. So even if the motor is bigger, you have to go by whatever the front of the old one was. You know what I'm saying? So this is where the shafts will line up.
Yep.
Now, when putting the blower back together, just remember that there's 2 channels that these brackets fit into. Remember to please slide them in between those channels so that the actual motor housing is secured in place.
You see kind of where the old one was?
Yeah.
You kind of tell, so we're going to just put this one against there. Your purples, again, I already looked at the specs, but this is going to be your capacitor, just like the old one was. but you always want to verify. In the motor, it'll tell you like what your capacitor wires are, what your medium and your speeds wires are. In this case, I already know that that's my capacitor. So I'm gonna lower this guy here. This back. This. Let me get that 1/4 inch nut driver right there. But it's not really going to do anything. Alright, so that takes care of that, that takes care of that. The reason why I put this here is because I don't like metal going against bare wire.
Yeah, because it'll rub through.
Yeah, creating a cold there. Now this limit, I have this wire here going from one end of the limit and to the other end of the limit. Oh, what the fuck? Well, that's not good. We're gonna have to change this connector. You have to go to the truck. On the floor of the truck, you'll see a clear bin with a bunch of connectors like this, spade connectors. Bring me that bin, please. And here, you might as well just take some out if you can. I'll hand it down. Turn it on.
Both of them or just the bottom one?
Both. The inducer just gets 120, like when you restart power, so that's normal.
Oh yeah.
Oh wait, we forgot.
I'll plug that in
You
already.
did?
Yep.
Look at you. Okay, good job. All right. Yeah, not bad, not bad. Yeah, I was just thinking, I'm looking through the limits, and I'm like, wait, because that's another limit. So that's
Right.
another safety that
Right.
the 24-volt circuit goes through in order for motor kicks on first. Just gotta close the pressure switch. Then go ahead and send a signal back to the board, and then you start to see the igniter go right here momentarily. See that?
Yeah.
Okay, so the igniter will start to glow, and then the gas valve is going to open, initiate the burner sequence, and then the flame will rectify back to the board and tell the blower to kick on and say, hey, there's a flame, you can kick on.
Oh, yeah.
And we should see this motor spinning with no problem. Alright, so there's that. You can see that right there. Blower kicked on. That's good. That's what we want to see. So just get this covered. Now what we're going to do is we're going to take a temperature rise. But I'll tell you in a minute what that is exactly. Okay. So what we want to see is to make sure that we have adequate temperatures from supply and return.
Okay.
So what we're going to do is we're going to put a meter over here.
Now you'll see there's a red dot in there as well. I put a probe before the filter and after the filter just to get a more accurate reading on the temperature split.
In a furnace, you want to see a degree differential between 40 and 60 degrees,
Okay.
based on whatever the manufacturer wants it to be. So in this case, the temp price here, let's see, they want between 30 and 60 degrees. So the difference between our supply temperature and our return temperature should be between 30 and 60 degrees,
Okay.
right? So depending on what we have there, you can kind of like, it'll tell you whether or not, like, if you're too hot, if you're too hot on this side, you might still have an airflow problem, something else going on,
Okay.
right? So you want to be within that range. Obviously, this is a twin system, so you're gonna have a lot of heat coming out.
Okay.
Now, obviously, we can take an temperature reading of the motor, and do some other steps to verify that it's within range. But right now, we're just gonna do a temperature rise, temperature split, and we should be good. It's maintaining the furnace running. Before, like, it will run, and then it'll run for like another like 2-3, like a minute, not even, and it'll shut it off.
Yeah.
Because it was getting way too hot. So now that we have air moving, we're not doing that. So what's the temperature of that?
I got 68 on the dot.
Alright, so 68, we got about 134, it's still climbing. So, let's see, we get to 140. Calculator. So 140 minus, what was it, 68 right there?
Yeah, 68. It's a
30 to 60.
36,
36. So we're 65. I mean, that's okay. It's a twin system, so it'll be okay.
And with this, we conclude the video. Heat is back up and running, and until next one. Any questions? Comment below.